Welcome to qnawire.
So we know that the wall is frictionless. And so to find the maximum frictional force, we simply just need to find the normal force exerted by the floor. So we can say that the sum of forces in the y direction equals 0. And this would say n sub 2 equals w sub 1 plus w sub m. And this is equaling 160 plus 740, so 900 newtons. So this would be the magnitude of the normal force exerted by the floor on the ladder. So we can say that the maximum friction is going to be equal to the coefficient of static friction. This would, of course, give us the maximum friction because the coefficient of kinetic friction is always less than the coefficient of static friction times, so it's mu sub s times n sub 2. And this would be 0.4 times 900, and this is giving us 360 newtons. So this would be your answer for part A. This would be the maximum frictional force, and this occurs between the point of contact of the ladder and the floor. For part B, they want us to find n sub 1, so this would be the normal force that is exerted by the wall on the ladder. So we can say that the sum of torques equals 0. Again, the ladder is in rotational equilibrium. This would equal 1.5 meters times 160 newtons plus 1 meter times 3 over 5 times 740 newtons, and then minus 4.0 meters times n sub 1. And we simply solve for n sub 1. So n sub 1 is going to be equal to 4 times 360, rather, my apologies, 1.5 times 160 plus 3 over 5 times 740, and this is going to be divided by 4 meters, so 4. And this is giving us 171 newtons. So this would be the magnitude of the normal force between the ladder and the wall. And lastly, we have part C. We still have rotational equilibrium. However, now they just want us to find x. So we can say that 4 meters times 360 newtons is going to equal 1.5 meters times 160 newtons plus x meters times 3 over 5 times 740 newtons. And we find that x is going to be equal to 4 times 360 minus 1.5 times 160 divided by 3 over 5 times 740. And this is giving us 2.70 meters. So this would be your value for x. This would be your answer for part C. That is the end of the solution. Thank you for watching.